Okay, here's problem number 3 from the practice test. It says the National Basketball Association is a league of 32 professional basketball teams in the United States. NBA games are typically high scoring. So we'll define the variable points scored as the total number of points scored in a single game by a single team in a game. The variable points scored is approximately normally distributed with a mean of 111.2 and a standard deviation of 12.7. What is the proportion of points scored that is between 100 and 120? Now, whenever I get these normal distribution problems, I like to draw a picture of what's going on. In this case, this picture is a distribution centered at 111.2. It has a standard deviation of 12.7. So we go about to the inflection point and we say, what is 111.2 plus the 12.7? And we get about 123.9. We can also do 111.2 minus the 12.7. And that takes us to about one standard deviation below, which is 98.5. All right. Now, what's being asked of us? We'd like to know how much is between 100, which is about there, and 120, which is about there. How much of the area under that curve? What is that proportion? Now, that proportion is going to be found by using the normal CDF functionality on your calculator. So let's go ahead. Let's go to second distributions, normal CDF. Our lower bound is that 100. Our upper bound is the 120. Our mean was given to us as 111.2, and our standard deviation was given as 12.7. And we hit enter. So I'm going to put all that in there: 100, 120, 111.2, and 12.7. I'm going to document all this. This is my lower. This is my upper. This is my mean. And this is my standard deviation. And out of the calculator, we get that this is about 0.56, let's 69, right? And let's see, does that look like about 57% of all the area under the curve? Yeah, about that, all right? Okay, second question. If the Detroit Pistons scored 98 points, and again, we're still coming from the same distribution in last week's game, centered at 100, there's 98, one standard deviation below, 98.5, about one standard deviation below, and here's the Detroit Pistons, and that little tail there. Okay, what percentile score? Well, the percentile score is, again, what percent is below a particular value. Again, we're going to use the normal CDF. This time, my lower bound is the smallest number I can put into the calculator, which is going to be 1e99. Negative 1 times 10 to the 99th power. Our upper bound is 98. Our mean is still 11.2. And our upper bound, or our standard deviation, is still 12.7. So again, lower, upper, mean, and standard deviation. So let's go ahead. Second distributions, normal CDF, negative 1, E99, upper 98, and our mean and standard deviation are still good. And we should get about 14.1493. Now, nearest whole number percentile is going to be the 15th percentile. All right. What is the cutoff for the highest 20% of points scored? Well, let's go ahead, draw the distribution one more time. And going up about 123, for that first standard deviation. We want to be about where the upper 20% is, something like that. Now for this, we're going to use an inverse normal because we're looking for a percentage, as we're starting with a percentage and trying to work backward to a value, where the other ones, we start with a value and we work backward to the percentage. So we can do it one of two ways. Here's the upper 20%, and here's the lower 80%. So if you have the newer calculator, the TI 84CE, you could say inverse norm, and you could specify we want the area to be 20% from this distribution that's centered at 111 and has a standard deviation of 12.7, and we want that 20% to be on the right tail. And we get, so document this, 0.2, 111.2, 12.7, and we want this to be the right tail. This is our area and our mean and our standard deviation. And this specifies again which tail. And we get a score of 121.88. Now, some calculators don't support that right-left thing. So and it defaults to the left distribution. So you could get the same answer from the older calculator by saying we want the lower 80% and specifying the left tail. And you'll see that we get exactly the same answer out from both of them. And that takes care of question number 3.